Hey guys, today in this video I'll be discussing about Hoffmann bromide reaction or rearrangement mechanism, which involves 3 steps and also a simple trick that takes 10 seconds. So, and if you feel that organic chemistry is very hard for you, you could just remember this trick. Okay, and at the end of this video I've covered very important examples of Hoffmann bromide reaction from previous entrance exams. Okay, coming to this reaction, Hoffmann bromide reaction is nothing but a reaction which involves the conversion of amide. So this is the amide, guys. So conversion of an amide into amine, that is primary amine. So Hoffmann bromide reaction converts a primary amide into amine. This is a amide group, guys. C double bond O NH2 is a amide group in the presence of bromine, sodium hydroxide and hydrolysis. Okay, this is the reaction. It's important to remember this reaction also. Coming to the mechanism, I'll just roll it down. So as I've told you before, there are 3 steps in this mechanism. I've just simplified this reaction into 3 by dividing this mechanism into 3 steps, guys. So if you feel that this mechanism is hard to remember, or if you're not an organic chemistry student, you can just skip this video of mechanism and see the trick. So in the overall mechanism, only this part of amide group reacts with the reactants. Okay, so in the first step, in the step 1, a base is added, that is sodium hydroxide is added. Sodium hydroxide abstracts a proton from this group. So after abstracting a proton from this nitrogen, it leaves in the form of water molecule, leading to the formation of this anion. Okay, this anion on nitrogen. This anion on nitrogen reacts with the bromine, leading to the formation of this N-bromamide. Okay, this is the first step, guys, and this is also intermediate. N-bromamide is also intermediate. So in the first step, conversion of this amide group to N-bromamide takes place. And coming to the second step, this N-bromamide is again made to react with this sodium hydroxide, and as usually sodium hydroxide abstracts a proton that is present on nitrogen and leaves in the form of water molecule, and there forms a very important compound that is called as N-bromamide anion, or sometimes it is called as nitrine, and these are intermediates, that is second intermediates. This is the first intermediate, guys, so and this is the second one. And in this second intermediate, this is a simultaneous reaction. So everything takes place simultaneously. These electrons on this nitrogen are transferred to this beside bond, and this alkyl group is shifted to this nitrogen, and as bromine is a leaving group, it just leaves like that, leading to the formation of this very important intermediate, that is this isocyanate. So in Hoffmann bromamide reaction or rearrangement, this isocyanate is very important, guys. So this intermediate is very important intermediate. In the first step, N-bromamide is the intermediate, and in the second step there are 2 intermediates, that is N-bromamide anion or nitrine and isocyanate. So these are the very important intermediates in Hoffmann bromamide reaction. So coming to this third step, in this third step hydrolysis of this isocyanate takes place, guys. So if we add a water molecule to this isocyanate, a very important compound is formed, this one, which is called as N-alkyl carbamic acid. As N-alkyl carbamic acid is highly unstable, it undergoes decarboxylation immediately, that is removal of this COOH group takes place simultaneously, leading to the formation of this primary amine, and release of this carbon dioxide also takes place. So if we add a water molecule to this isocyanate, directly amines are formed. If we add a methanol to this isocyanate, methyl carbamate is formed. This compound is called as methyl carbamate, guys. So methyl carbamate is formed. Methyl carbamate on hydrolysis leads to the formation of these primary amines. Okay. Coming to the examples, I'll tell you how to remember this Hoffmann bromide reaction with these examples only, that is this trick to remember this Hoffmann bromide reaction. Okay, I'll just roll it down. Firstly, it is very important to remember these reagents, guys, that is bromine, sodium hydroxide and water molecule. So it is very important to note these reagents. If you ever see these reagents in any question, Just remember that it is directly a Hoffmann bromamide reaction. And coming to this reagent, in this reagent it is very important to see where the amide group is. So just catch this amide group. In this amide group, identify the C double bond O of amide group. Identify the C double bond O of this amide group, and while answering, just remove that C double bond O group, guys. That's it. It's very simple. So just remove this C double bond O group and write the answer. So that is the answer directly without any mechanism. Okay, so this is a simple trick, guys. Just remove this C double bond O that is attached to this NH2, guys. Coming to this second example, so this is the second example, guys. So if we apply our trick to this second example, just see this amide group. From this amide group, remove this C double bond O and write the answer. So that's it, guys. It's very simple. Just remove the C double bond O of amide group and write the answer. And also please note that these reagents does not affect any of these groups, whether it is nitro or halo groups, any other groups. So these reagents does not affect any other groups, guys. So it just attacks this amide group. And coming to the third example, very important example. In this third example, there is a configuration, guys. So we'll just assign this configuration. This is first preference, this is second, this is third, and this is fourth. And the configuration is, as it is anti-clockwise, it is S. So this compound is S configured compound. So let's just apply a trick, that is just remove this C double bond O of amide group and write the answer. And let's write this configuration for this product also. Okay, so this is first, this is second, and this is third and fourth. So the configuration is anti-clockwise S configuration. So the configuration did not change, guys. So even in the reagents and the products, there is a same configuration, that is called as retention of configuration. So configuration did not change at all. So it's easy to just apply this trick, that is removal of C double bond O, and nothing will be changed, only this C double bond O is removed. So that is how you remember this trick and apply to the examples. These are few very important Hoffmann rearrangement examples, guys. So coming to the first example, if you see this reagent, instead of this bromine, sodium hydroxide and water, please don't panic, guys, because this reagent is also similar to that of Hoffmann reagents only. So it also works in the similar way. And if you see these reagents or these reagents, simply apply a trick. Okay, so just remove this C double bond O and write the answer. That's it. That is simple. And this is the intermediate, that is isocyanate intermediate. Okay, coming to the second example. In this second example also, this is a amide group, and I have just removed this C double bond O and written this amine group. As I have told you, there is no change in configuration, so retention of configuration takes place. And I'll just roll it down. Yeah, so this is a GATE 2013 question, guys. So in this question, this is a phthalimide. Okay, in this phthalimide reacts with this Hoffmann reagents to form amines. So I've just given this mechanism. You can just note down the mechanism, or I'll just tell you this simple trick. As I've told you that Hoffmann rearrangement is used to the formation of primary amines. So in which of the following options you can see amines? Only this first option. In only this first option you can see amine. So directly with this trick you can just correct the option. Okay, and this is a mechanism. This is the mechanism, guys. So you can just pause the video and note down the mechanism. This is a June 2015 CSIR question, guys. So they just gave this compound and these reagents and asked for the product and also intermediate. So as I have told you, these reagents are Hoffmann reagents. If you see anywhere these reagents, just apply our trick, that is remove the C double bond O and write the answer. And that's it, guys. And I've also told you that these reagents does not affect any other groups, whether it is halo group or nitro group. It does not affect any other group. Just remove the C double bond O and write the answer, guys. And there are three important intermediates in Hoffmann rearrangement. That is, in step 1 it was N-bromamide, and in step 2 it was N-bromamide anion or nitrene, and also isocyanate. So these are the three important intermediates that you have to remember in Hofmann rearrangement. Okay, and the answer is A, because you can see only this in this option, you can see this nitrogen intermediate. And coming to the another question, this is a TS set question, guys. So they just gave this compound and these reagents. So firstly they gave these reagents as instead of bromine and sodium hydroxide, they gave this bromine and potassium hydroxide. As potassium and sodium comes under same group, it doesn't matter, guys. So this potassium hydroxide also used as Hofmann reagents. Okay, coming to the mechanism, in this mechanism I have used these reagents to convert this amide into amine. Okay, so this is a Hofmann rearrangement. The first step is the Hofmann rearrangement, and then they gave this sodium nitrite. Okay, they gave this sodium nitrite. Sodium nitrite converts this amine group into quaternary ammonium salts. Okay, so to this quaternary ammonium salts, if we add sulfuric acid, formation of alcohol takes place. So the answer is A. And that's it, guys. That's it for today. Keep going, keep practicing, and keep encouraging. Thank you for watching this video.